In Module 3, Lesson 6, we're going to look at rational numbers on the number line. So to start off, we want to make sure that we can convert fractions to decimals and decimals back to fractions. In the opening exercise, we're going to start with fractions to decimals. And our first fraction is 1/2. There are two ways we can change a fraction to a decimal. The first one would be to simply divide the numerator by the denominator, and the second would be to make equivalent fractions, and then that equivalent fraction could go straight to a decimal. So I'll show both ways, just as a reminder to you. The first way would be to divide the numerator by the denominator. So when we're dividing the numerator by the denominator, the top number, or the numerator, goes inside the box, and the bottom number goes outside. Typically in these situations, we'll have to add a decimal point and zeros in order for us to get a decimal answer. We will not put remainder or R anything. When we add a decimal point and a zero, we have to drag that decimal point up into the space for our quotient as well. And then we'll divide without really paying much attention to where the decimal point is in our dividend. So 10 divided by 2 is 5, and that 5 has to go directly above the last digit that we were considering in the division. We were looking at 10 and 0 being our last digit. So the 5, the number of times that 2 goes into 10, goes directly above that 0 since it was the last digit in the number we were looking at. 5 times 2 is 10. And when we subtract, we get 0. When we get 0 as a remainder, we know that we're finished. So 1/2 as a decimal is 0.5 or 0.5. The other way is that we can make equivalent fractions. And to make equivalent fractions, what we want is a 10, 100, or 1,000, a power of 10, in the denominator. Then all we need to do is figure out how many times we multiply our original denominator to get the new one, which is 5. And we do exactly the same thing in the numerator. So 1 times 5 is 5. And we can see that 1/2 is 5/10. And as long as we know our decimal place value, we can write 5/10 the same way that we found it by dividing. Let's try it again with 4/5. This time, let's make an equivalent fraction first. 5 does go into 10, so the denominator we'll be looking for is 10. And 5 times 2 equals 10, so we'll have to multiply by the same number in the numerator, and 4 times 2 is 8. And 8/10 looks like that. If you're a little shaky on your decimal place value, this would be a good time to brush up. The first place value position is the tenths, then the hundredths, and the thousandths, and continuing with that pattern. Our last example is 6 and 7/10, so it's a mixed number. When we convert a mixed number to a decimal, the whole number part does not change. So we'll write 6, and then we put a decimal point after our whole number. And this particular fraction already has a 10 in the denominator. So we can write 0.7, which is 7/10. Next, we're going to convert decimals back to fractions. This process requires us to know our decimal place value. So if you haven't brushed up on it, now is the time. When we read this decimal, we read after the decimal point, we read all of the digits as a number, as if it were a whole number. So this is 42. And then in the denominator, we put the place value position of the last digit. So this was tenths, this is hundredths, and in the denominator we put hundredths. It's also a good idea to simplify our fractions after we change them. And 42 and 100 are both divisible by 2. So we'll divide them both by 2 to simplify. 42 divided by 2 is 21. 100 divided by 2 is 50. So our final answer would be 21/50ths. The next two examples are going to end up being mixed numbers. And we know that because there is a whole number in front of the decimal point. So that whole number will not change. That will just simply be written. And the fraction part we will write just the same way that we wrote our first fraction, by reading the digits after the decimal point as if they were a whole number. So that's 75. That goes in your numerator. And the denominator is the place value position of the last digit in your decimals. Tenths, 100ths. So in the denominator, we put 100. 75 100ths can be simplified. And I know that both of them are divisible by 25. I always like to think about money, since there are 100 cents in a dollar, and I know that 25 cents is a quarter. 3/4 is 75. It's good to have those little tricks to help you do your math a little faster. 75 divided by 25 is 3. 3/4 are 75. And 100 divided by 25 is 4. 4/4 are a dollar. So what we find then in our final answer is that 3 and 75 100ths is the same as 3 and 3/4. And finally, our last example. There's a 36 in front of the decimal point, so we write that whole number. And then after the decimal point, we have 90. That's our numerator. And the denominator is the place value position of the last digit. Tenths, 100ths. So in our denominator, we put 100. 90 and 100 are both divisible by 10. I know that because they end in a 0. Now I can do that writing divided by 10, divided by 10. And I will do that for this exercise, but when you divide by 10, all you're really doing is moving the decimal point over one place. So I would end up with 9/10, which I can do without even doing the actual division. So our final answer is 36 and 9/10. In example 1, graphing the rational numbers, there is a description of the process at the top of that page, which probably tends to be even more confusing. But let me put it in real language for you. They're saying that if you have a fraction, 1 over some number, then you're going to need to divide the spaces on your number line so that that bottom number, your denominator of your fraction, is one of the divisions. then you can graph your fractions easily on the lines instead of trying to approximate someone in someplace in between. And they continue with the description in the second paragraph. Don't let this stuff scare you, because this sentence, in the third paragraph, is what we really have to do with the number line. They asked us to locate and graph the number 3/10 and its opposite on a number line. Now, when I see directions that tell me I have to graph a number and its opposite, I know that means that 0 has to be on my number line, because I cannot graph a number and its opposite unless I have 0. And under those circumstances, I normally go to somewhere near the center of the number line, and it doesn't have to be exact. And that's where I put my 0. Next, what I'll need to do is number the number line so that I can locate 3/10. So what I can do is number my number line by tenths. This would be 1/10, 2/10, and 3/10. We can number our number line many different ways, but the most important thing is that each space from one line to the next has to be the same distance. So I can't just skip to 3/10 and then go 4/10, 5/10. That doesn't work because that's not equal intervals. Looking at the left side of 0, I would follow the same pattern, but my numbers would be negative. So -1/10, -2/10, and -3/10. I'm not continuing to number the number line because I only have to locate 3/10 and its opposite on the number line, and I already know that I have those two numbers. So finally, what I'll do is go down to my number line and first of all locate 3/10. It tends to be a little easier to locate your positive number first. And on the number line, I'll put a dot. This is what we call graphing, or putting a point on the line. And then to graph the opposite of 3/10, we would go 3/10 to the left of 0, which is -3/10, and we're finished. Exercise 1 tells us to use what we know about the points -7/4 and its opposite to graph both points on the number line below. And then it's going to ask us a question about that, but we want to make sure that we do things in order. We're going to graph our points first, and I will choose a 0. Approximately in the middle. And I know because the 4 is in the denominator that I'm going to have to divide my spaces into fourths. 1/4, 2/4. This could be called 1/2, but I'm going to leave them as fourths for this number line. It'll be easier for us to read. I also know that 4/4 is 1 whole. I'm going to make a mark up here that tells me it's 1 whole. Then 5/4, 6/4, and finally 7/4. And since I know that that's where I'm going to be ending, I won't number the rest. On the other side of 0, I'm going to start with -1/4, -2/4, So I'm also going to write the whole numbers 2 and -2, since I found as I was going that I was almost to -2 and almost +2. We have to graph -7/4 and its opposite. So the first thing I'll do is go down to -7/4, and we put a dot on the line. And then the opposite of -7/4 would be +7/4, and we'll put a dot there. Next, we'll look at the question. The fraction -7/4 is located between which two consecutive integers? A consecutive integer is one that is right next to each other when you are counting or looking on the number line. And integers are not fractional parts. The integers are without fractions or decimals. So -7/4 is in between these two integers. And then our answer, and we'll go down to the sentence and fill that in with on the number line, each segment will have an equal length of 1/4. In the fraction -7/4, the numerator is -7, and the denominator is 4. So the fraction is located between -2 and -1. In example 2, which is our last example for this lesson, we'll be looking at a vertical number line. And vertical number lines oftentimes tend to be a little more confusing when we first start to learn negative numbers. So we want to make sure that we're extra careful. It says the water level of a lake rose 1 and 2/25 feet after it rained. We're going to answer the questions using the diagram. The rational number to represent the situation, since the water level rose, would be a positive number, +1 and 2/25. Then it asks what two integers is 1 and 2/25 between on a number line. And hopefully at this point we know that it is above 1 but below 2. So we would say it is between 1 and 2. Next, they want to know what the length of each segment on the number line should be, and we should write that as a decimal and a fraction. Well, the decimal, if we want to land exactly on one of the lines, the decimal would have to be 25/100. And 25/100 as a fraction, let's go ahead and write that. Hopefully we remember from earlier on that both 25 and 100 are divisible by 25. And so the equivalent fraction would be 1/4. 25 goes into 25 once, 25 goes into 100 4 times. So if our water level is at 0, after it rains, we will be at 1 and 2/25. And they ask us to graph that point on the number line. Our next question, after 2 weeks of rain, the water level of the lake is the opposite of the water level before it rained. I believe we have a little bit of a typo going on there. I would say that we need to change this to after 2 weeks without rain, since we are going to be graphing the opposite. But let's go ahead and graph the opposite number first. It would be -1 and 2/25. which is moving towards -2 from -1. And then we'll make a little change. And then that makes a little more sense. Finally, in question F, they asked us to say a rational number that is not an integer, whose value is less than 1 and 25 hundredths, and describe its location between two consecutive integers on the number line. And so looking at our number line, we're looking for an integer, a rational number that is not an integer, and is less than 1 and 25 hundredths. This was our 1 and 25 hundredths here. We want something less than that. So if we selected this point right here, that would be 75 hundredths. And 75 hundredths is between 0 and 1. Our integers, you'll notice, are on the right. In the second exercise, you're asked to write a real-world story problem of your own using a rational number and its opposite. When you write that, please make sure, even though integers are rational numbers, please make sure that you use not an integer, but a rational number that includes a fraction or a decimal.